Assalamu alaikum. Right, so we'll dive into the question and answer. We've been assigned an assignment to discuss what is a sensor. Right, so moving on to there, we would discuss that there are numerous definitions as to what a sensor is. But if we particularly needed to define a sensor, then that would be an input device which provides an output signal with respect to a specific physical quantity. The term input device in this definition of a sensor would mean that it would be a part of a bigger system which provides input to a main control system like a processor or a microcontroller. Other than that, there's also another definition of a sensor. It is a device that converts signals from one energy domain to electrical domain. The definition of the sensor can be better understood if we take an example into consideration. Right, so in this figure you can see there are different type of sensors ranging from color sensor, gas sensor, LDR, the most common one, light sensor resistor sensor, proximity sensor, ultrasonic sensor, infrared receiver, water flow sensor, humidity sensor, touch sensor, and many more. Right, the simplest example of a sensor would be an LDR or light dependent sensor. It is a device whose resistance varies according to the intensity of light it is subjected to. When the light falling on the LDR is more, its resistance becomes less since they are indirectly proportional, and when the light is less, well, the resistance would become very high. We can connect this LDR in a voltage divider along with other resistor and check the voltage drop across the LDR. This voltage can be calibrated to the amount of light falling on the LDR, hence a light sensor. The sensors below can be classified into different types. There are several classifications we can divide them. Some experts and authors have given this as some are very simple and some are very complex. The following classification of sensors may already be used by an expert in the subject, but this is a very simple classification of sensors. In the first classification of sensors, they are divided into active and passive. Active sensors would be those which require an external excitation signal or a power signal. Passive sensors, on the other hand, would not require any external power signal and would directly generate the output response, completely different than what the active sensors are. The other type of classification would be based on the means of detection used in the sensor. Some of the means of detection would be electric, biological, chemical, and radioactive, etc. The next classification would be based on conversion phenomena, the input and the output. Some of the common conversion phenomena would be photoelectric, thermoelectric, electrochemical, and electromagnetic. The final classification of these sensors would be analog and digital. Analog sensors would be those which provide an analog input, while on the other hand, digital would be those which work with discrete or digital data. A data in the digital sensors, which is also used for conversion and transmission, is digital in nature. Now moving on to these different type of sensors. There is a list below of different type of sensors that are commonly used in various applications. All these sensors would be used for measuring one of the physical properties like temperature, resistance, capacitance, conduction, and heat transfer. Temperature sensor, proximity sensor, accelerometer, IR sensor, which is in short for infrared sensor, pressure sensor, light sensor, ultrasonic sensor, smoke gas and alcohol sensor, touch sensor, color sensor, humidity sensor, position sensor, magnetic sensor, microphone sound sensor, tilt sensor, flow and level sensor, touch sensor, and finally strain and weight sensor. A temperature sensor, one of the most common and most popular sensor would be the temperature sensor. A temperature sensor, as the name suggests, would be the one which senses the temperature. That is, it measures the change in the temperature. The figures are here given below for this case. This is for LM35 sensor, temperature sensor IC, and a 10 kilo ohm NTC sensor. There are different models to these temperature sensors which are given below, like ICs like LM35DS18B20, thermistors, thermocouples, RTT, which are the resistive temperature devices. So these temperature sensors can be analog or digital. In an analog temperature sensor, the change in the temperature would correspond to change in the physical property like resistance or voltage. LM35 would be the classic analog temperature sensor. Coming to the digital temperature sensor, the output would be of discrete value as we have discussed above. The DS18B20 is a simple digital temperature sensor. Temperature sensors are used everywhere, like computers, mobile phones, automobiles, conditioning systems, and industries, etc. A simple project that we can make by using LM35 would be the temperature control system. It would be in the Celsius scale temperature sensor. If you just look below on the screen, you would see the data sheet provided for this particular sensor LM35. So yeah, its data sheet is here. The output voltage is in there. Uncalibrated temperature error, minimum and max values as well. It's for 25 degrees centigrade, and when the current is 1 milliampere. The non-linearity would be in this case as well. That's given here as well. Electrical parameters would be given in this case as well. The output voltage change with current, dynamic impedance, temperature coefficient of output voltage, time constant, and time stability. All of these are given. Um, for the time constant, there are two types given. The one in still air and the one for still oil. Infrared sensor, which is in short for IR sensor, are light-based sensors that are used in various applications like proximity and object detection. IR sensors, they are used as proximity sensors in almost all the mobile phones. That means the one you're carrying, the one mobile phone you're carrying with you in your pockets or are using currently, like I'm using one to make this video, it has an IR sensor in it, a proximity sensor in it. This is the figure for the IR infrared sensor. This is for the reflective type. There are two type of infrared or IR sensors: transmissive type and reflective type. In transmissive type, the infrared sensor, the infrared transmitter, which is usually an infrared LED, and the infrared detector, usually a photodiode, are positioned facing each other so that when an object passes between them, the sensor quickly detects the object. There's another type of there's another type of infrared sensor which we just looked at above when I showed you the figure. In this, the transmitter and the detector are positioned adjacent to each other facing the object. When this object comes in front of the sensor, the infrared from the IR transmitter, sorry, when an object comes in front of the sensor, the infrared light from the IR transmitter is reflected from the object and is detected by the IR receiver, and thus the sensor detects the object. Uh, Different applications, since it's been asked by our professor to give different applications of these sensors as well. So different applications where the infrared sensors can be implemented would be mobile phones, robots, industrial assembly, and automobiles, etc. Mobile phones are one of the most common things we use in our daily life. It's almost as essential to our daily life. It's become a part of us, you can say that, because we are constantly doing our job, texting people, and do whatnot. Do a lot of stuff using these mobile phones. Robots, they're part of our future now. Uh, it is thought that they would be the beacon that we need to progress into the future. Automobiles, another thing that we use. A small project where these IR sensors are used is to turn on street lights. So you probably have wondered how the street lights uh, are turned on and off. So infrared sensors are used in these. So that's something I think so that you didn't know. So yeah, if you look on the screen now, you would see the data sheet provided the absolute maximum ratings as well as the electrical and optical characteristics. Since we were also asked about the characteristics of these sensors, so here are some given in the data sheet as well. Um, yeah, there's supply voltage, supply current, output current, junction temperature, power consumption, and other things. There is also minimum irradiance and maximum irradiance, and also directivity. So ultrasonic sensor, if we move on to the next type of sensor, it is an ultrasonic one. It is a non-contact type of device that can be used to measure distance as well as velocity of an object. An ultrasonic sensor would work based on the properties of sound waves with frequency greater than that of human audible range. So it's gonna have a range then more greater than that of which humans can hear. And it's that kind of sensor. It works on the properties of those sound waves. So that's something really unique, if you ask me. That's a sensor that works on the properties of sound waves and has the frequency greater than that in we humans have. Ultrasonic sensor, there uh, is a figure of HCSRO4 model of the ultrasonic sensor, the one which I use to explain about ultrasonic sensors. Using the time of flight of sound wave, an ultrasonic sensor can measure the distance of object similar to sonar. The Doppler shift property of sound wave is used to measure the velocity of an object. Arduino-based rangefinder is a simple project using ultrasonic sensor, portable ultrasonic range meter. Here's the data sheet given. The model is HCSR04, like I explained before. The voltage, echo, ground, all of these things are explained in the module pin definitions. Electrical parameters, operating voltage, operating current, operating frequency, the farthest and the nearest range are also given here, which are 4 meter and 2 centimeter, respectively. The measuring angle is given, which is 15 degrees. Input trigger signal is given, which is 10 US TDL pulse. The dimensions are given as well. So now, next up, we have the light sensor, sometimes also known as photosensor. The light sensors are one of the important sensors. A simple sensor available today is light dependent resistor or LDR. The property of LDR is that its resistance is inversely proportional to intensity of the light. That is, when intensity of light increases, the resistance decreases, and vice versa. Since they are inversely proportional, so that's the case when the light would increase, then its resistance would decrease, and the other way around when the light decreases. By using the LDR in a circuit, we can calibrate the changes in its resistance to measure the intensity of light. There are two other light sensors or photosensor which are often used in complex electronic system design. They are photodiode and phototransistors respectively. All these are analog sensors. The figure is given here of what a light sensor is. There are also digital light sensors. The model names are given, which can calculate the intensity of light and provide a digital equivalent value. Sorry. The data sheet is given here as well. The applications are given here of a light sensor. It is high sensitivity alcohol and quick response in resume, widely used in portable alcohol gas detector. So yeah, its data sheet is given with standard circuit conditions, sensor character under standard test conditions, standard test conditions, and etc. All of these things. The next up is a smoke and gas sensor. One of the very useful sensors in safety related applications are the smoke and gas sensors. Almost all offices and industries are equipped with several smoke detectors which detect any smoke due to fire and sound an alarm. The gas sensors would be the most common one in laboratories, large scale kitchens and industries. They can detect different gases like LPG, propane, butane, and methane, etc. So this is the one. Suppose that you had a fire in your house. So these type of sensors are the one which detect it and quickly catch it and help you uh, it can help you know that there's a fire in your house, and they certainly the alarms go off. And the sensors that are used in these alarms are the smoke and gas ones. Nowadays, the smoke sensors, which often can detect smoke as well as gas, are also installed in most homes as a safety measure. The MQ series of sensors are a bunch of cheap sensors for detecting carbon dioxide, carbon monoxide, methane, alcohol, propane, butane, etc. You can use these sensors to build your own smoke sensor application. The data sheet is given, but before we dive into the data sheet, I'll take you to the features of these type of sensors. These are wide detecting scope. They have a stable and long life. They have fast response and high sensitivity. They possess high sensitivity, and they are simple drive circuit. Now, for the application of these would be they are used in gas leakage detecting equipments in family and industry are suitable for detecting of butane, propane, methane, alcohol, hydrogen, and smoke. The data sheet is given here as well. The standard conditions are given on which they normally work. The environment conditions are given. The sensitivity characteristics are also given. Uh, the ranges of these temperatures are given in here as well. The room temperature and etc. etc. The standard detecting conditions are also given, which is temperature 20 to 2 degrees centigrade. The humidity is given. The preheat time of this is all sensors is also given, which is over 24 hours. If you dive into these things, the detecting concentration would be given in as well. The 200 uh, to 500 is the range of that. The alcohol sensor would be the last one, which we'll discuss today. As the name suggests, it would detect alcohol. So usually these alcohol sensors are used in breathalyzer devices, which determine whether a person is drunk or not. So something that you probably didn't know till yet would be the thing that how do we see if someone is drunk or not? Because there are certain people who, after drinking a lot of alcohol and after a certain amount of time, don't necessarily show the signs that a drunk person usually does. So for that, the police or FBI or any kind of these criminal protecting services, I'll say, they use these kind of sensors to detect whether a person is actually drunk or not. That's what is written on your screen here in the last line. Enforcement personnel use breathalyzers to catch drunk and drive culprits. So usually, people that drink they are also involved in hit and run cases and uh, driving cases and whatnot. So in these mostly in these type of cases, these type of sensors are used to detect in machine to detect whether a person is actually drunk or not. The picture of this sensor is given. The model is MQ3. Uh, for the data sheet, the supply voltage is given in this case. The output breakdown voltage is given. The supply current is given. The output current is given. The maximum power dissipation is given. Operating ambient temperature is given. Storage temperature range is given, and soldering temperature range is given. The electrical characteristics in this case are also given, since we were asked about information related to these sensors as well as applications. So the application I've already explained in this case of sensor. It would be the one for the machines that we use to detect whether the people are drunk or not. As for the characteristics, the electrical characteristics are given here. Uh, Now you can see them on your screen, and that would be it related to my sensors. If I can just quickly explain to you how many sensors and what we have done here today. So yeah, moving on, that we discussed about the temperature sensor. uh, Related to it, we discussed about its applications, discussed that there are different type of actual temperature sensors. We discussed that one of its application is the temperature control system. We discussed about the characteristics, which included electrical as well as temperature characteristics. The infrared sensor or IR sensor, we discussed about that as well. Uh, the reflective type, at least in that case. We discussed that its application was that it was used to turn on street lights. We also discussed about the electrical and optical characteristic as well as the mechanism of this type of sensor. We also discussed about the ultrasonic sensor, which works on the properties of sound waves, which are greater than uh, sound waves with frequency, which is greater than the human audible range. Yeah, also about this, we uh, saw different things about this, the Doppler shift property to measure the velocity of an object. We discussed about its electrical characteristics as well as optical and other characteristics. Light sensor was one of the important sensors we discussed today. We discussed it about what things the sensor do, what's its application, and all other things, etc. We also saw the data sheet of this type of sensor. Then we had the smoke and gas detect sensors, which are generally used in our homes to detect the fire, or industries as well to detect the fire or any certain case like these. Mostly they are used in kitchen and industries. Another one, its features were given. There was also application of it, and we also discussed about its characteristics. Finally, we had the alcohol sensor, which was used to detect alcohol, which we don't know were involved in drunk and hit and run cases and drunk cases, where the police organizations usually use these kind of sensors. We also discussed about its electrical characteristics, and that was where we concluded our conversation on these sensors and what they do, their purpose, their mechanism, applications, and as well as characteristics. Thank you, and Allah Hafiz.